Welcome you all. Myself Nagarajan, Assistant Professor in EC Department, Rohini College of Engineering and Technology. In this course, we will see about the embedded system and IoT subject for biomedical engineers. The topic is a secured architecture for IoT and enabled personalized healthcare system. So secured architecture, first introductions of a secured architecture in IoT healthcare system. Secured architecture means it is referred to the design and implementation of systems that protect against unauthorized access, data breaches and cyber attack. The main objective of this secured architecture is to ensure the confidentiality, integrity and availability of sensitive health data in IoT enabled personalized healthcare system. And next, we will discuss about the components of secured architecture. So first one is a data encryption. In encryption techniques, we have using a symmetric encryption as well as the asymmetric encryption. In a symmetric encryption, it uses the same key for both encryption and decryption. For example, AES algorithm. In asymmetric means it uses a pair of keys, public and private for encryption and decryption. For example, RSC algorithm, that is a reversed Samir Adleman algorithm. And next, implementation. So encrypt data stored on devices and transmitted over network to protect it from unauthorized access. For example, encrypting health records and communication between IoT devices and cloud services. And second component is a authentication and access control. In a authentication method, we followed a two things. One is a multi-factor authentication and second one is a OAuth and OpenID Connect. So multi-factor authentication, that is a MFA, means it requires a multiple forms of verification. For example, password, biometrics and security token. These are things. For example, using fingerprint scanning along with the password for accessing healthcare application. So OpenID Connect, it is a standard for secure authentication and authorization. For example, allowing user to access healthcare services through third-party credential while maintaining secure access control. Next one is a access control. So in access control, we have here two things. One is a role-based access control, another one is a attribute-based access control. In a role-based access control, role-based access control is assigned permission based on user roles and responsibilities. For example, restricting access to sensitive patient data based on rules. For example, doctor with administrative staff. And next, attribute-based access control means it will be uses the attributes, for example, user role, location to make access control decision. For example, let us consider granting access based on user attributes and context such as a time of access or location. Next one is a network security. So network security protocols, that is a firewalls. So firewalls is monitor and controlling incoming and outgoing network traffic based on predetermined security rules. For example, implementing firewalls to protect IoT devices and healthcare networks from unauthorized access. And next one is a intrusion detection and prevention system, that is a IDPS. It will be detect and respond to potential security threats and anomalies. For example, is using IDPS to monitor network traffic for suspicious activities and respond to potential threats. And next one is a secure communication protocol. So here we follow, that is a two things. One is a HTTPS and TLS SSL. A secure communication channel over the internet using encryption, and VPNs, that is a virtual virtual private networks. It will be create secure connection over public networks. And fourth component is a data integrity and backup. So data integrity is using a hash function. It generates unique digital signature for data to verify its integrity. And digital signature is authenticate the origin and integrity of data. Then data backup. So data backup means backup strategies. Regularly create and store copies of data to protect against loss or corruptions. So best practice for securing IoT healthcare system. We regular security updates and patching, security awareness and training, and then incident response planning. These three things are best practice for our secure our IoT healthcare system. Then challenges in securing IoT healthcare system. So device heterogeneity, that is address security challenge arising from the diversity of IoT devices and platform. Scalability. Second thing is a scalability challenge, device heterogeneity and scalability. Thank you.